Organic chemistry, alkanes. So alkanes, these are saturated hydrocarbons. So alkanes, they are the main hydrocarbons that are found in petroleum and natural gas. So the general formula for alkanes is is C subscript of N H subscript of 2N plus 2, where N is the number of carbon atoms, is the number of carbon atoms. That is the value for N. So the alkanes, they do not form polymers. Okay. Then alkanes, they are insoluble in water. Alkanes, they've got a single bond between carbon atoms. That's why they are called saturated hydrocarbons. They are unreactive. Okay, so their bond is strong. So that makes it to be unreactive. They are reactive because their bond is strong. So you need to understand that this group of compounds, which are alkanes or the homologous series, the alkanes, the first compound to the fourth compound, they are gases. So the first to the fourth compounds, they are gases. That's what we need to understand. Then from 5th to 16th compounds, they are liquids. Then above 17, they are solids. Very important. So 5 to 16 compounds are liquids. So above 17, they are solids. So this is all about the alkanes. So when you look at that table, we have the first element, which is methane. So we have the molecular formula, the structure formula. So how do you make the molecular formula? I want to show you the molecular formula and the structure formula, what it means. So we have methane. So methane, it's a first compound in this family. So it has one carbon atom. So when we look at the general formula that we have, it is Cn2n plus 2. So where n, it means the number of carbon atoms. So we are going to pick this one and put it there. So we have 1. H2 times 1 plus 2. We have C1. We don't write the subscript of 1. So 2 times 1, that is 2, plus 2, that is 4. So this is the molecular formula. So this is the molecular formula. But the structure formula, it is going to be like this. So we have 1 carbon atom and we have 4 hydrogen atoms. So this is the structure formula. So if they say the structure formula, this is the structure formula. If they say the molecular formula, this is the molecular formula. That is it, the way it is. That is the way it is. So the second compound, it is methane. Then we have propane, butane, pentane, hexane, heptane, octone, nonane, decane. So that is what we have. So chemical reactions of alkanes. So number one, combustion. So when we talk about combustion, we're talking about the burning of a substance in air. That is combustion. So you have to take note that there is no reaction that occurs when an alkane is mixed with the oxygen at room temperature and pressure. But when a flame or a spark is added, exothermic reaction takes place, and that is what we call combustion. So very important point. When a substance is burnt in air, so is a combustion reaction where it is given out. That is a exothermic reaction. Okay, when we just add oxygen to a substance at room temperature and pressure, then that is not combustion. Okay, so for combustion of alkanes, an alkane it must be heated in air to produce a substance and heat. So now we have two types of combustion. There is what we call a complete combustion, and there is what we call incomplete combustion. So we start with a complete combustion. So when we talk about a complete combustion of alkanes, so alkane they are burnt in an unlimited oxygen, which is air, to form carbon dioxide and water and heat. So that is what we call complete combustion. So in complete combustion, we have unlimited supply of oxygen. So alkane. So in the complete combustion, carbon dioxide, water, and heat, they are what? Produced. So the production of heat, this is what makes alkane to be used as a what? As a fuel. So we have alkane plus oxygen. We are going to have carbon dioxide plus water plus heat. So this, we are saying that it's the reason why alkanes are used as a fuel. So we have an example, it is methane. Methane plus oxygen. We are going to have carbon dioxide plus water. That is our balanced chemical equation. So the second one, we have what we call incomplete combustion. So incomplete combustion, this is the burning of a substance in a limited oxygen to form a poisonous carbon monoxide and the water. So that is what we call incomplete combustion. So the difference between complete and incomplete combustions is that in complete combustion, carbon dioxide is given. In incomplete combustion, carbon monoxide is given. Why? Because there is a limited supply of oxygen. So we have alkane plus oxygen. We have carbon monoxide plus water plus heat. So example, we have methane plus oxygen. We have carbon monoxide plus water. So that is the balanced chemical equation. Then the second reaction of alkanes, it is substitution. So remember that these alkanes, they are unreactive. So they do not go addition reaction. So they do not undergo addition reaction. Instead, they undergo substitution reaction. So substitution, what is substitution reaction? It's a reaction in which one atom or group of atoms in a molecule is replaced by another. This is what we call substitution. So now, the alkanes, they undergo substitution under condition of so there are two conditions for substitution reaction. Substitution reaction of alkanes, it must take place under high light intensity, then also high temperature. So what is the purpose of light? The purpose of light intensity or ultraviolet, it is to break the bonds and then it will react. So now the products that we have when substitution reaction undergoes. So, so when methane reacts with chlorine, so what we have is when one hydrogen atom is substituted and replaced with one chlorine atom, what we have is monochloromethane plus hydrogen chloride. So we have methane plus chlorine. So we are going to have, when one hydrogen atom is replaced, we remain with 3 chlorine plus hydrogen chloride gas. That's what we have. So for the structure formula that we have, this is what we have. That is the structure that we have. Okay, and this is hydrogen chloride gas. So if two hydrogen atoms are replaced, we are going to have dichloromethane. So when two hydrogen atoms are replaced by two chlorine atoms, we are going to have this is what we call dichloromethane plus hydrogen chloride. Okay, so the structure, we are going to have chlorine this side, chlorine that side. Then when three hydrogen atoms are replaced by three chlorine atoms, we are going to have trichloromethane. So when three hydrogen atoms are replaced by three chlorine atoms, we are going to have trichloromethane. So trichloromethane. So when four hydrogen atoms are replaced by four chlorine atoms, we are going to have tetrachloromethane. So this is what we call tetrachloromethane. That's what we are going to have. And the structure is going to be like this. Plus hydrogen chloride. So remember that this one, it is taking place under the condition of light intensity to break the bonds of what? Uh, Chlorine.